Alrighty. Hello, everybody, and welcome to the Marshall W. Allworth Planetarium. My name is Braden. I'm a student worker here at UMD, and it is my wonderful job to help run this awesome place. Back there is helping me out tonight. We also have Jessica and Ben, and I have a wonderful show for you guys this wonderful Wonderstruck Wednesday. It's my favorite show because I get to talk about Star Wars for 30 minutes. So this is Star Wars Fact or Fiction. With that, we're going to take a look-see at kind of everything that we can really see in Star Wars, see how scientifically accurate it is, see some if things are more fact or if they're more fiction. It'll be very, very fun. That's going to be about 30 minutes. Once that is done, that's going to be it. I do just have a couple of safety announcements I have to go over before I do get started. Number one, it's going to get quite dark in here. If you ever have to leave at any point during the show, please exit through the entrance you guys came in. We have glow-in-the-dark tape around the planetarium I'd like you to observe. Please use that to find your way out. Last thing we want is anyone tripping on their face while they're on the way to the bathroom, which, speaking of, bathrooms are located on either side of that giant telescope as you saw as you're entering the building today. Yeah, if you guys ever have any questions or at all, feel free to raise your hand and I'll get to them as soon as possible. Same for the people at home, because we are also streaming this on Facebook Live, because this was something that came out of back when we had COVID times and we had live streamed free shows on Wednesdays, and now we're back here again, which is still always good to be reminded of. But without further ado, I'm gonna head back there and get us started. So now let's dim these lights and, yeah, get started with Star Wars, fact or fiction. Now, Star Wars is probably one of the most famous, probably one of the most famous pop culture movie series of all time. I'm sure basically every generation has grown up watching a new set of movies. My parents' generation grew up watching like A New Hope and everything like that. My generation grew up watching the prequels, and now this new generation has grown up watching the sequels as well as the other Disney Star Wars shows. So Star Wars has literally touched most people's lives in some way. But let's look at the ways that they've kind of touched science, because they've dabbled in it. It's a science fiction property. So let's see how right they are. But I personally feel like there's no better way to get started with the Star Wars show than something like this. So that was made by a wonderful old coworker of mine named Eli. This was actually originally his show that I officially took over last year, and now I've put my own little spin on it. But let's start off with probably the most famous scene in Star Wars, the binary sunset scene, where we see Luke here looking up on Tatooine, gazing up into the future. The classic hero's call to adventure. I'll let the scene play out because it is an absolute classic. But is this real? And the answer is yeah. Tatooine is a planet that orbits a binary star. Two stars that orbit each other. That's what we see in this iconic, epic double sunset scene. These binary stars exist elsewhere in our universe, and they actually make up about 85% of star systems that we at least believe to be at least a binary. Well, some could be even a ternary or a quaternary. That video that we just saw right there shows how these binary stars orbit. They will orbit around each other if they are equal mass, but if they have differences in masses, as we could see pictured here, the orbits will change. As we see, the larger object will have a smaller rotation, while the smaller object will be launched out and get pulled back in to the orbits around. We can see an excellent example of a binary star system in the Sirius star system. Another very famous one would be the Mizar and Alcor system, which is actually not a double binary, but in fact a binary and a quaternary. That's going to be the two stars in the bend of the Big Dipper. But I want to take a look-see at the Sirius system because I think it showcases it a little bit better. As we're looking around it, I'll kind of back up a little bit more to take a better look-see. We can see how they orbit around each other here. Where did my laser pointer go? Right here. How they each have their own orbits. So we have the bigger star right here that has a slightly smaller orbit, with the smaller star right here having a larger orbit as it gets sent out from the mass of the bigger star. So that is actually fact, which is good job, Star Wars. Now moving on, we're going to head to our next region, which is going to be the asteroid fields. So in Star Wars, we see asteroid fields a lot. Specifically, we see them in Empire Strikes Back with Han Solo's iconic scene where he's bobbing and weaving through the dense asteroid field. And we do see these in our own universe as well. Probably the most famous of which is going to be our asteroid belt in our solar system. The asteroid belt is a collection of rocky material left over from the creation of our solar system. So the question here is are they going to appear like they do here in the movies? Not entirely the case. So you do have asteroid fields, and they are going to have a bunch of space rocks, basically, but it's not going to work out as you may expect. For example, if you took the Millennium Falcon and flew through our asteroid belt right here, you could fly for a couple of months and actually not see a single asteroid. Why is that? Because the asteroid belt is actually going to be mostly empty space, because space is mostly empty space. In fact, a probe flying through our asteroid belt has less than a 1 in a billion chance of colliding with something. And multiple have traversed the region without at least imaging one asteroid. And talking more about asteroids in space, let's talk about a very controversial scene, in my opinion. This is a scene from Attack of the Clones. Stand by. So what we're imaging there is Obi-Wan is flying through one of the rings of the planet Geonosis. And in this ring, it's mostly rocky debris. Geonosis looks fairly similar to Saturn, although in actual makeup it is not. But Geonosis is more akin to Mars than it is to Saturn, although it is actually the size of Saturn in Star Wars lore. What we're picturing here, I'm actually going to play it one more time because I hate it. But we are seeing what is called a seismic charge, which kind of launches what is essentially just an earthquake in space. Now, this is not possible. We've all heard that there's no sound in space fact more than once. That is where we have to fully suspend our disbelief with Star Wars, with all of the TIE fighters flying sounds, the wow and everything like that. We all kind of accept that that's just a bit of science fiction embellishment here. But this is just completely wrong. So in space, there is no medium for the waves to propagate through. So you see, sound is a vibration of air molecules, and we hear it as air, or like my speech, wobbles in your eardrums, which our brain pieces together as sound. Seismic waves, as such seen here from the Slave 1, are waves propagated through the Earth's crust, which is the result of an earthquake or some sort of collision. In space, there's no vibration for this to happen, and thus these effects and the cool sounds are sadly impossible. So that is a bit more fiction than fact. But let's look at something that Star Wars actually gets pretty right a lot of the time. And that is going to be the conversation of habitable zones. Now, as we fly to probably the most famous habitable zone in our galaxy, that's going to be our own, with our sun. So we have a habitable zone right here. Habitable zones are zones around the stars that which life could be supported, essentially. It has a name that I like a lot more, otherwise known as the Goldilocks zone. And we can take a look-see at the habitable zone in our sun. So we have red, green, and blue. Red representing too hot, the Papa Bear. Blue representing too cold, the Mama Bear. And then we got just right in the middle, where we have, I believe, where we actually have the Earth existing right about there. We can also see Mercury and Venus right there as well, but Earth exists perfectly in the habitable zone. This assumes that all extraterrestrial life would share the requirements of life as Earth. The hotter the star gets, the further away this range actually extends. We see this vaguely in Star Wars, as different worlds would exhibit different qualities that we see on planets. As where essentially hotter stars have their planets existing further away that sustain life, while colder stars have their planets a bit closer that sustain life. And we can see it a little bit here in this wonderful image right here, where we have Endor, the forest moon, existing in the habitable zone, Hoth existing right outside of the habitable zone because it's an ice planet, ice and snow planet, and Tatooine right on the cusp of the habitable zone since it is an arid desert planet. We can see an excellent example of some extraterrestrial habitable zones with the wonderful star system known as the TRAPPIST system. The TRAPPIST system you've probably heard of back in like 2015 and made some pretty big rounds around, having some some exoplanets that caught the attention of astronomers. But as we fly to the TRAPPIST system, we can use it to fly around. Where'd you go? So the TRAPPIST system has, oh my gosh, about, can I count? I believe about 7 stars, 7 planets. What am I talking about? And about 3 of them actually exist in this habitable zone. So Star Wars is pretty correct when it comes to a lot of their planets, actually, which is pretty impressive. But now we're going to move on to our next question, which is the Star Wars galaxy. How accurate to being a galaxy is it? And actually, pretty accurate. The Star Wars galaxy is a spiral galaxy, meaning that it's the galaxy is shaped like a disc with spiral arms kind of coming out around it. The central area is, in this case, elongated into a bit more of a spherical shape, while in most galaxies, it's going to be a bit more of a bar shape. But it's actually not entirely the most inaccurate. And we can actually compare it to a wonderful model, which is our galaxy, the Milky Way. which we're going to fly out and take a better look-see at. As we fly out and take a better and get a more bird's eye view of our galaxy, we can think about the similarities. So in the Star Wars universe, we're a bit dim. So in the Star Wars universe, in the Star Wars universe, the galaxy has about 400 billion stars in it. In comparison to our galaxy, the Milky Way, we have about 200 billion stars in it. So the Star Wars galaxy is roughly double the size of our own, the Milky Way. In light years, it has a diameter of about 120,000 light years, while our galaxy has about 100,000 light years. There you go, that's a better imaging. As we fly around our Milky Way also has a supermassive black hole that exists in the middle. And this is actually very similar to Star Wars. Star Wars also has a supermassive black hole that exists in the middle of its galaxy that is aptly named the galaxy's center, which is a pretty good name. Our name, I think, is a bit better, which is Sagittarius A star, since it exists in the constellation of Sagittarius. But from there, let's take another look-see at the Star Wars galaxy. This one a bit better, though. We can see those spiral arms a little bit more, as well as we can see some of the names of the planets. We have Tatooine right there, Coruscant, and Ilum over here. And I actually want to talk about these two, Ilum and Tatooine. Because now we got to talk about the actual distance in space. So the galaxy in Star Wars is about 120,000 light years in diameter. And traveling in space is really, really no easy feat. So we'll talk about hyperspeed momentarily, but let's get a really good idea of how large distances through space really are. The fastest speed reached by a man-made object was about 153,000 miles per hour by the Parker Solar Probe back in 2018. Even traveling at this speed, it would still take about 40 days to get from Earth to Mars, two planets in the same solar system. So if we wanted to go from one planet to another on the other side of the galaxy, for example, Tatooine right here and Ilum right there, it would take about 462 billion years, or about 33 times the age of the universe. So sadly, there's not enough coaxium or kyber crystals to do that for you. Now, this is just another little tangent that I wanted to talk about. I love the way that any science fiction will explain space travel, because they will make up like some just weird elements that helps them do it. In Star Wars, it's coaxium. In Star Trek, it's dilithium crystals. Like it never really makes sense, but it's cute. It's what they do in order to kind of explain the basics. But now let's talk about another very famous scene in Star Wars, or maybe one that's more famous talked about, which is the Kessel Run. And it's actually one thing that Star Wars really did get right, and pretty well as well. So one thing that Star Wars did get right is Han Solo's famous line, "The Millennium Falcon made the Kessel Run in about 12 parsecs." At first, it sounds like Han is saying, "I made this drive in this distance," which would be like saying, "I drove from Minneapolis to Los Angeles in 20 miles. Which, yeah, doesn't make sense. But a parsec is a unit of distance equal to just over about 3 light years. Obviously, this sounds wrong. But what Han was actually saying, that since the Millennium Falcon is so fast, he was able to take essentially a what am I trying to say? He was intentionally able to take a shortcut through a dangerous region of space to make the trip shorter. The Kessel Run is a maze-like region of space surrounding the planet of Kessel, which is like a mining world in Star Wars. And it is littered in a bunch of in essentially a bunch of nebulae that kind of orbit around the planet. And the only way to get it is through the Kessel Run route, which is this kind of maze-like trade route right here. Now, the route that they took, the risky route that the Millennium Falcon took through, is going to be through this nebulae right there. And in this nebulae is going to be a region of space that I love that is called the Maw. The Maw is essentially a bunch of collections of black holes that kind of are all collapsing in on itself. In the lore of Star Wars, it's actually a prison that is holding like this super evil like space witch named Abeloth, which is, it sounds cooler than it actually is. But we can actually see this right here, and also we can see how they try to use hyperspace right here. Anyways, if you have not seen the movie Solo: A Star Wars Story, I highly recommend it. I believe it is very underrated. Now, in order for ships to travel great distances in short amount of time, they enter a dimension they call hyperspace. Hyperspace essentially acts as a shortcut between point A and point B. In order to get there, ships must reach the speed of light. While hyperspeed is a nice way to get some lore behind the mystery of going to light speed, the bigger problem is actually getting to light speed. As an object's speed increases, it takes more and more energy to accelerate it and get it to greater speeds. In this, it's explained that coaxium is one of the things that does that. But once the speed of an object starts to getting to speeds in 10 to the percent of speed of light, the energy required to accelerate them further becomes increasingly large. And the closer to the speed of light it becomes, it essentially becomes effectively impossible. Additionally, rather than launch you from low speeds to light speeds very quickly, as seen in Star Wars, you'd have to gradually increase your speed, as the inertia would kill you if you jumped fast enough. This is why in Star Trek you have stuff such as inertial dampeners. Now let's look at some things that look similar to our things that look similar to some planets in Star Wars. So yes, sadly, hyperspace is not real. Hate to break it to you. The first planet I want to talk about is around the star 55 Cancri, specifically 55 Cancri E. And these are just all complete coincidences, but I love this planet. 55 Cancri E, otherwise what I like to call real-life Mustafar. So Mustafar is a planet from Star Wars Episode 3, Revenge of the Sith. And it is the lava planet where Anakin and Obi-Wan have their epic battle, the one that goes on for about 20-ish minutes. But so we're currently looking at the backside of it. But as I orbit around the front, we can see a better view, and we can see all of the lava around it. And I believe it's one of my favorites. We can see how it compares to Mustafar with this imaging as well. Now, in the lore, Mustafar is actually further away from its star. So sadly, Star Wars does lose some points in that for the reason that 55 Cancri is so hot is due to its proximity to its star. But another thing with 55 Cancri is going to be this. This is what we call the Exoplanet Travel Bureau. This exists from this exists on NASA's website, and it's just a wonderful little image of 55 Cancri E, lava life. Now we're going to head to our next region, which is going to be a little moon around Saturn called Mimas. Now, Mimas is just a rocky little moon, which when we fly to it, may not look like much originally. But trust me, it gets fairly similar. As we fly to Mimas, Mimas was a moon when discovered. We didn't know the correlation here. So as we fly to Mimas, again, it doesn't look like much originally. Mimas itself was discovered back. Oh my gosh, I'm trying to find the exact age. Where is it? Mimas, oh, it's in the dark. Okay, so what we're looking at right here, there's a little crater which can be seen right there. This crater looks very, very similar to a specific thing that we know in Star Wars that we probably all know and love, the Death Star. And it's actually because it's actually pretty similar to our the Death Star, and the fact that this crater actually emits radiation, very similar to the Death Star's space lasers. Now from there, let's head to our last very similar thing in our galaxy that looks something similar to Star Wars, which is going to be Earth. Earth is very similar to a specific planet in the Star Wars universe that we visit quite a bit in the prequels. This planet is named Naboo. In fact, they are both actually in the same distance from their stars. Naboo is based on the Earth, in fact, and they're around the same size as well in Star Wars, and they both have life. Although we here don't have fish people like the Gungans do on Naboo. But from here, we're now going to move on to a bit more of a more science-y portion of this show, which we're going to talk about flight in Star Wars. In Star Wars, we see very few differences between flight on a planet and flight in space, when in reality, they'd be very different experiences. On a planet with an atmosphere, your craft is subjected to many forces imparted in the air you're flying through. In order to turn, as we can see imaged here from the Star Wars movie The Last Jedi, you have to complete a banked turn. A banked turn is where the plane slightly tilts to one side. As the direction of the force changes, the plane will begin to follow a circular path as the lift force and the force of gravity combine to pull the plane to one side. We can see it kind of imaged right here with the way that lift works, with the plane turning to one side to pull it up with this. Now, in space, without the presence of an atmosphere, slash a planet supplying lift and gravity, we'd have to create our own forces to move a ship. For example, if we wanted our Millennium Falcon to move in the direction of the Green Arrow, for example, we would need the Force is represented by the yellow arrows in order to move to the green arrows. We can show this kind of like this. In order to move it kind of like this. Although this is not entirely possible with the way the Millennium Falcon works. You see, the Millennium Falcon only has one thruster. So you would sadly get a forever Millennium Falcon only moving straight. You would need thrusters on all sides in order for the Falcon to go the way you do. So sadly, Star Wars gets a few points knocked off for that. But now let's talk about one of the last things we're going to talk about tonight, and that is the blaster. Commonly mistaken as lasers, blaster fire, otherwise known as bolts of intense plasma energy, converted from what is known as Rick gas in Star Wars. While this may sound like the work of science fiction, it's actually entirely possible, and it's actually already been done. You see, plasma is the fourth state of matter, in which charged particles like electrons detach from atoms and flow freely. The bolts we see here would be plasmoids, globs of plasma held into a distinct shape by an electric or magnetic field. These fields can be generated as the bolts travel by shaping them into a spheromag, which is a configuration of plasma that would generate magnetic fields as the plasma moves. Pictured here, imaged here. These plasma burns thousands of times the temperature of the sun, which could really cause some damage to whatever they hit. While the typical Star Wars blaster may be a bit out of reach with our current technology, the ideas behind it aren't entirely possible. And we may have some type of plasma weaponry in the future. Now, let's do the grand finale. The lightsaber. While lightsabers are really the coolest thing that I've ever heard, and honestly, something I've been wishing for ever since I was a baby for Christmas, they don't quite work out the way that we would hope. Lightsabers could be constructed in the same way that blaster bolts are made, with the plasma containing a self-generated magnetic field, or with the lasers generated in the hilt, but the energy required to consistently heat the plasma or power the laser would be far too much for the hilt to hold. Also, there'd be no way to stop the plasma at the end of the blade, and you would be left with an infinitely long blade, basically, which is not very convenient. If it were made of light, you'd have to stop it with some type of mirror, which not only ruins your ability to stab with the saber, but it would also send the light back at the hilt and ruin it. We also run into the problem of cooling the hilt, which would take more energy and space than is available in the hilt of the blade. Not to mention the battle constraints would be devastating. Since the plasma is extremely light and light is massless, the weight and balance would all be in the hilt, unlike a sword where the weight balance is somewhere in the middle. This would make swinging the blade very difficult, also due to the fact that plasma and light aren't very solid. We'd get none of the cool noises made by the clash together. They'd simply just pass through each other. So, ever so sadly, Luke, this is not entirely possible.
Father's lightsaber. This is the weapon of the Jedi Knight. Not as clumsy or random as a blaster. Elegant weapon for a more civilized age.
I don't want to end on a totally dream-crushing note, however. So if we look at the closest thing that we have to a lightsaber, that is going to be a proto-saber, which is actually lore accurate and is actually the first times that lightsabers existed in Star Wars. This was going to be back in the times of the Old Republic. The popular YouTuber engineer Hacksmith, this weapon, a lightsaber attached with the battery pack, has a tungsten blade that heats up to about 300,000 degrees, hot enough to cut through many materials. And it's the closest thing we have to a lightsaber at this point. I'd recommend checking out this video on YouTube. I will say it's not a very kid-friendly channel. Which, at the end, brings us to the end of our show. So I ask, are there any questions that we have in the audience. If not, I would like to thank you all so much for coming out here this lovely, lovely night. You guys were a great crowd. Thank you all so much, and I'm just glad that I got to talk about Star Wars. I love it a lot. As you're heading out, do a double check that you have everything that you need. You know, phone, wallet, keys, small children. That stuff tends to get left behind, so just make sure you have it. But other than that, that's all I have for you.